Hey, good people. I hope you're doing well. In my last video, I told you that we'll start from here. In my last video, we just designed this kind of fiber, right? So now we want to move on to our structure. Okay, so just give me a second. Hi. Okay, welcome back. Okay, so. What I told you that we'll just recreate this model. Okay, we'll recreate this model, right? So from today, I'll start to creating this model actually. So in the geometry, what we see that we create this kind of geometry, but we didn't create the gold layer and PML. Okay, so for PML layer, we just only select this kind of thickness, but um, to get better result or errorless result, we must select a perfect PML layer actually. So what is perfect PML layer, right? So you need to know. So here you can see that if we just remove this into two, this layer actually in here, right? After that, what we have to do, we have to add at least, so what will happen actually in PML layer? Let me clear it. So when light will go pass through the fiber, then some light actually may leak from the fiber and they may reflect from the boundary of the PML and they come back and they may mixed up with our signal and make a give us some wrong result, right? So what we have to do, we have to just absorb the whole light that get leaked from the fiber. Okay, so we need to add this kind of PML. So at least the thickness of PML should be the half of the wavelength. Okay, so and some simulation setup or some software may require full wavelength thickness is equal to the full wavelength of light. Okay, but COMSOL does have that comfort that you can just select the thickness of PML half of the wavelength. Okay, so so in our simulation, we actually run our simulation from maybe 300 nanometer to mm, sometimes we may go through 25,000 nanometer. Okay, so oh sorry, 25 not 25,000, 2,500 nanometer maximum. Sometimes someone actually simulate till 3,000 nanometer. But uh, for this work, maybe we can see how much we actually simulate. So you can see that they simulate till 2,700 nanometers. So we have to divide 2,700 divided by 2. So we need the thickness of PML 2,700 nanometer divided by 2. Okay, so we have to select it as nanometer because the unit is, as you can see, the unit is micrometer. So here the unit is micrometer, right? So the PML layer thickness is 2,700 nanometer divided by 2. So here you can see that we select the PML thickness is 2,700 nanometer divided by 2. That was our maximum wavelength. Um, Initially, we select the thickness of PML more than we require actually. Oh, I'm sorry. Actually, this is the radius. So we don't need to divide it actually. So So this is our PML. Okay, it's okay. You can select PML more than 2700 nanometer. It's okay. It's up to you. But please don't took not thinker PML. Okay, it may hamper your result. Okay, that's all. So what I did before, we did just oh, we just uh, produce this draw this actually setup. So now what we have to do, we need to um, okay. So for delete entities, you can drag up here and you can delete these air holes. Okay, as well. Okay, sorry, this one, this one. Okay, please check the paper first. Okay, so we need to okay. Oh, this thing here. Okay, okay. This sorry, this one, not this one. Okay. So, and another thing you have to do, you have to add a small air hole here and a big air hole for this two air hole. Replace with of this two air hole. Okay. So at first, how we can do? Okay. Uh, this is the air hole. Okay. So let me check. Okay, so you can just duplicate this air hole. Okay, duplicate. Okay, so what I am doing here actually, you can look, I just built selected up to this delete entities, and then we duplicate this circle. So that's how actually the circle duplicate here. If we just build all the selected, then the duplicate circle will come here. Okay, so okay, the radius of this circle is actually, let me check, the radius of this circle is actually d3, right? So this resolution is very less. Well, I don't know why. Okay, d3. Okay, and what we can do, we can just mirror this circle. So from sorry, okay, from transforms, we can mirror this circle. Mirror, then we have to select this circle and get input object obviously and build. So this circle is get mirrored. Okay, let check this. We have to select normal vector to line reflection. X is 1 and y 0, and the point of reflection is 0 0. Okay, it's the center point. Okay. So we got the circle actually. And then what we have to do, we have to redraw this two circle. Okay, small circle actually. Okay, so for that, uh, okay, for that we have to just what we can do actually. Okay, uh, to make it easy actually, you can draw it in complex way, but to make it easy, what I can do, again I can duplicate this circle. So let's check what I did. Okay, um, the diameter of this circle actually d2, right? Okay, d2. Okay, let's see. Okay, so you may not understand what I am doing actually, so I'll explain, no problem. So let's see. Then what I can do, uh, we just can duplicate this array. Okay, then duplicate this array and then select this small here. Then build. Oh, sorry, not 4, just 2. Okay, build this. Okay, then we can just mirror, duplicate this mirror. Okay, then we don't need to select all of this. We just remove this and select this one, then build. Okay, we got this 2 ear hole, and then we can just duplicate this mirror again. Okay, deselect all and select this one and this one, then build selected. That's how it's work. So what we have to do now, we have to, okay, here we have got one delete interface, so we can duplicate it. Okay, then we have to delete this small ear hole, this small ear hole, as well as this ear, sorry, this ear hole, this ear hole, this big ear hole, this big ear hole, big ear hole, big ear hole. Okay, now build selected. There you go. Okay, that's how actually it works. Okay, now, okay, sorry. Now we have to build this channel actually. So here you can see the height of this channel. Okay, not we don't need to think about height right now. What you have to do, we have to just take a line segment. Okay, so sorry, line segment. I'm sorry, not line segment. Okay, okay, another way. Okay. I said did a click on Ctrl Z. That's how it's delete, but you can delete it manually. Delete. Okay, there you go. Okay, then from geometry, what you can do? Um, okay, okay, another way. You have another way. You can see this kind of interface from geometry. What you can do? We can. Why is it? Okay, we can select polymer. Okay, then we can manually, sorry, no, we can't manually draw it. But what we can do, this is X direction, this is Y direction. So the starting point of the polymer should be from maybe, I don't know, but what's the position of this? I don't know how they actually create the channel. Okay, maybe there is another way. Not polygon, Control Z. Okay, there is another way. I know it. So you have to select rectangle. Select rectangle, and then the weight of the rectangle you can select maybe 1. It's okay, and the height. Okay, let's see. So this is the rectangle, but we need it. Okay, height should be 10, maybe not 10, 100. Okay, so ours. We don't need 100 actually. We can select it as 50. So 50 is okay, maybe. Okay. We don't need 50. We can, no, 25 is not enough. Yes, 40 is enough. Okay. But we have to rotate it. Rotate at 45 degree maybe. It's working. But the problem is you have to um, select the position. Okay, no, not 45, maybe 40 is okay. Let's see what happened actually. I don't know how they create, but we can guess just, right? Okay. Um, 20 micrometer. Oh, sorry, not 20. 5 micrometer. Okay, now maybe it's kind of better. All right. Yeah, I got the point. Okay, don't worry about it. 27. Yeah, let me check. Okay, not actually 27, but 28. Yeah, but what you have to do, you have to select it as 6. Then you have to select it as 29. Maybe I am just thinking that this distance between this uh, two here, 16 or 19.3. Okay, no worries. Okay, it's maybe kind of uh, okay. Okay. So then what we can do, we can select a mirror. Sorry, we can select a mirror. We have to mirror this rectangle. So I have to mirror it, not in extra. Sorry, keep in input objects actually. So we mirror it. Okay, it's okay. So here you can see that every setting is okay. We mirrored the rectangle and it's working perfectly. And then we need the height of the gold layer. Okay, so height is, we already select the height as you know in our first second video. So already select height as is on. Okay, so now what we have to do, we have to create another sorry rectangle, and the weight of the rectangle, let me check, weight maybe okay, okay, tg is the thickness of gold. Okay, weight maybe tg, and height maybe we can select is 20. I don't know. Okay, sorry, height is 20. Okay, so 1300. Okay, it's wrong actually. So weight will be 20, height will be tg. Okay, but the problem is the position, right? We have to change the position. So we have to select center. Uh, okay, no, sorry. We have to select corner because the distance. Okay. Then we have to change the x position 10. Oh, sorry, minus 10. We have to shift it in a minus x direction. So minus 10, and the position. Now you have to select the position that is A zone. Okay, that is A zone. Okay, there you go. So it's working, right? Perfectly it's working. So you can select it as 15, maybe 15 is good. Okay, but at the same time you have to change it, right? Okay, this is 15 divided by 2, right? Okay, maybe you have to change it and 10. Okay, 10 is perfect. So that's okay. Now what you have to do is the most important part of this work. Okay, what you have to do, you have to um, convert it, convert this three rectangle to curve. Okay, so this one convert to curve, this one and this one, and will selected. So we just convert this three rectangle to curve. Okay. Then we have to delete some thing. Okay. So from delete entities and look here, we select boundary. That's how we can select this boundary. Okay. Okay. So let's see. Okay. Now, uh, now I want to just select this one. Okay. Not sorry. Um, Another thing I want to do actually from convert to curve, we want to convert this circle. We want to convert this circle as well to curve. Okay. Okay. From delete entities. Uh, Select all the things. Okay. So now what we have to do, we have to select this one, and this one, and let me set. Okay. Then select this one and this one as well as this one. So select this one, and here you have to let me do it for you. This one, you have to select this one, and this small one is very tough to select, so you can click here and select it. Okay. So it's very helpful, right? Okay. And then you have to select this one. You don't need to select these two, okay? But you have to select this small one, okay? So we select it, and you have to select this one as well. Okay. Okay, and you have to select all the things of here. Okay, so you can select directly this way. Okay, and then zoom in. You have to select this one, and this one as well. This one. Okay, and this one as well. Right? Okay. I think you are understanding what I am doing actually. If you don't, you can ask me. Okay. And then what you have to do, we have to select this one as well as this one. Okay. And we have to select this one as well. Okay. Maybe we can be selected now. Okay. I think, oh, I'm sorry. Here you can see something is not selected. So we can just select this way. This is very cool right now. Okay. Okay. Everything is fine, right? Okay. If everything is fine, then what you can do actually, um, we can, uh, okay, the problem is, you can see that, uh, I know what's the problem, but for you, I can make it easy. Okay. So you can delete and this one as well, because we'll face some problem if we don't delete this. Okay. Oh, sorry. Uh, First activate and then select this, and this one. Okay. Now what you have to do from geometry, you have to convert this curve into solid. Okay, this curve into solid. I'm sorry, what I did. Oh, no. Sorry. Don't convert it, delete. So from geometry, okay, I'm sorry. Let me check. Geometry, that is, let me check. If we select, just let me check it. Okay, if we select this one, all the curve is selected, right? Okay, then it will work. Okay, no problem. So now what you have to do, you have to just mirror this curve. Okay, mirror. You have to mirror this to with respect to y-axis. So you have to select it as 1, sorry 0, and you have to select it as 1. Can keep input object, obviously. Be selected. Here you go. So you can see that this curve actually duplicate here. Oh, sorry, mirror here. And now what you have to do, you know that we just delete our curve, sorry, our circle. So we can duplicate this circle because we just, right? No, 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 no. This circle we just need to duplicate. Okay, this circle we need to duplicate, right? So we delete this circuit, right? Yeah, we delete this circuit. So we have to duplicate it. So duplicate this circle, and here you can see that this circle is working perfectly. So what you have to do, you have to convert this circle into curve. Okay, then we'll select it. Okay, so this circle is perfectly curved. Then from geometry, you have to convert again. Sorry, you have to select from Boolean. You have to select union, and then you have to select this one, and this one, and okay, keep in inner boundaries. Then build selected. So you can see that we just okay, here you can see that this is the gold layer. Okay, here you can see that we union all the things. Okay, so then you from geometry you can do convert this curve uh, into solid. Okay, so then we'll select it. So here you can see we just convert it as solid. Okay, so, oh, I'm sorry. So it's okay, but what you have to do, you have to delete this the curve, right? This one. Okay, so from this again we have to select delete entities, and then you have to, okay, not here, from here you have to union. Okay, did union and then delete entities. Okay, then you can select this one, this one, this one, this one, will selected, and then converts to solid and convert to solid. Yes, yes, we did it, we did it. Okay, so here you go, we actually did it. Okay, so you can see we just convert our circular PCF into just X shape, P shape, right? So thank you for supporting me. I don't know. Okay, so now we have to select the material. So this all are the, sorry, sorry, no. Sorry, this all are the ear hole. Okay, I'm sorry. Okay, then we have to select this one as well. Okay, this all are the ear hole. Mhm. And then we select it as water, but we don't need to select it as water right now. And this one was silicon dioxide, and it should be silicon dioxide right now, but we don't want to use it as silicon dioxide right now because we have in our last video I share you that um, um, this value of refractive index is wavelength dependent. So you have to select wavelength dependent silicon dioxide, right? So we can just delete this silicon dioxide and this two as well, and also we can delete this silicon dioxide actually. Okay, now we have to import our material from some material. Okay, I do have some material, but at first what I want to do, I want to add another parameters. So this parameters for geometry actually. Okay, I can write it. Okay, this parameter was for geometry, and these parameters we want to this parameter for materials actually. Okay, this parameters for materials. Okay, so we need the materials property of silicon dioxide, gold, and analytes. Okay, so we need all the material properties. So how we can get this kind of materials properties? So I build lots of PCF-based sensor. Okay, so I do have the material property in my laptop, so I can import it and I can share with you actually. Um, so okay, sorry. I have to import it, right? Okay, from where I can import it? I know from where I have to import it. COMSOL PCF. Where is the PCF? Yes, and from PCF, okay, this one is for gold. Okay, maybe this one has all the material property, I think. Okay, this one is parameter files. Maybe this one has all the material property. I'm pretty confused right now. Let's check. Override. Okay, I override something. So let's check. This thing I override actually. Okay, this one has all material property. I will explain all the material property, and I will also upload this material property in the comment box. Oh, sorry, description box. You can download this material property from there. Uh, okay. If I didn't upload this material property, please look the material property here from here. Okay. So sometimes I forgot to upload the material property, but I can just wait for you. You can check this material property from here. So in the paper, I don't know, it's the same with the paper. If it is the same with the paper, so in the paper they actually define the Selmer coefficient. And you can see they define the Selmer coefficient. Okay, so this is A1, A2, A3, and B1, B2, B3. I'm sorry. So here you can see this actually A1, A2, A3, B1, B2, B3. They are actually Selmer coefficient, and this is the Selmer equation. Okay, so let me make it easy for you. This is this one is the actual equation. So square root first bracket, then 1 plus double first bracket, then A1 into first bracket. L is the wavelength actually here. L to the power 2, then first bracket, and then so you can look this equation. So this equation is the same of the paper. So this equation, we write this equation in the COMSOL. This is how you can write the equation here. Okay. So write this equation from here. Okay. So this is how we can calculate the refractive index of silicon. Okay. So let me check. This is how we can calculate the refractive index of silicon. So this is the, okay, here you can see L is the wavelength. Okay. And here you can see this is lambda is the wavelength. Okay. 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 Then write the equation, and then okay, let me check the refractive index or lambda. Uh, sorry. Let me check the L. Okay. Where is the L? I'm not finding. So this one is the L actually. Yeah, in the geometry we define it L, but we can take it from here, cut, and we can paste it here. So here you can see we just remove the L. That's why all the equation are red right now. Okay, so paste the L here. Okay, then you can see that all the equation is correct right now. So here you can see that the wavelength here is 0.65. So at the wavelength of 0.65, the refractive index of sorry, uh, the refractive index of silica is 1.4524. Okay, so okay, and then what you have to write? So this one is the refractive index of silica, and then you have to calculate the value for gold. Okay, you have to write the Lorentz equation. Okay, so for gold, actually, we don't need the Lorentz equation. Uh, I'm sorry. Let me check what I did. Let me check. Why it's reduced? Okay, check. Um, piece the value. Okay, so the parameter value of piece uh, TG and is D1, D2, D3 changed actually from the with respect to parameters value from the file. So we have to change it again. Okay, I'm sorry for that because we upload the parameter file and the parameter files um, PTG was the different from the paper. Okay, so okay. Now for the gold, you have to, yeah, we just use epsilon infinity. Okay, so let me check. Okay, the epsilon infinity, this is the epsilon infinity. Okay, let me zoom it for you. So we have to calculate the, uh, uh, this one is actually the permittivity. Okay, so permittivity of gold. So we have to calculate the permittivity of gold. So the epsilon infinite is equal to here you can see that 5.973 and then omega. OMG is omega actually. Here you can see that omega. We have to select the omega. This is the omega. 2 into pi into c constant divided by lambda. Okay, so we know the omega is the angular velocity, right? That is 2 pi divided by lambda. Sorry, 2 pi divided by f. So f is equal to c by lambda actually. So then omega t. So here you can see that we have omega uh, sorry, omega d actually. So we have to define it actually. So omega d, we defined omega d, then id, then de, then we just cl and rl, and then we calculate the refractive index of sorry, permittivity of gold. Then we calculate the real part of permittivity, imaginary part of permittivity. Then we calculate the refractive index of from the permittivity. We calculate the refractive index of gold and a real part of refractive index and the imaginary part of refractive index. Okay, and this is Na. Na is the refractive index of analyte. Okay, Na is the refractive index of analyte, and W, we don't need W actually. You can delete it. Okay, you can delete it. We don't need W actually from for this model. Okay, so you can see this all are the parameters value of the model, and then parameter of geometry. For the parameter of geometry, you can see that it's changed. Just override the parameters. So you have to put it as 9 as paper mentioned. The mm, piece was 9. Thickness of gold was 30. So you have to put it as 30. ASON was 1.6 lambda. So it is 1.6 lambda. Then d1 is 0.65 lambda. d1 is 0.65, 0.34, d2 is 0.34. d2 is 0.34, okay, and d3 is 0.85 lambda. d3 is 0.85 lambda. Okay, everything is okay right now. Okay, okay, what is it? So someone actually asks why we need to define actually is on D on D2, D3 with respect to P piece. Okay, so the answer is right now you can see you see that we change the value of P the value of TZ, but there is no effect actually. We just create a complex design, so sometimes it may happen that your model is just got distracted. Okay, so you need to create this model again, but uh, if you just connect all the parameters with the piece, then if you change the piece, all parameter will change, and then your model will the shape of your model will be exactly like the past. Okay, so you don't need to fix it again and again. So that's the thing actually. Okay, I think you understand. Okay, so from the material now we can add material from so we can add a blank material. So uh, rename it as silicon SiO2, silicon dioxide, or silica. Its name is silica actually. So the refractive index of sorry, let me check. Okay, okay, sorry, from material. The real part of NEFF is NEFF. Actually, it's this is the real part. Okay, there is no imaginary part. Sorry. Okay, this is the real part. Okay, the imaginary part is kind of zero, so you don't need to worry about it. And then again another blank material. So this one will be gold AG. Sorry, AU. Okay, the gold layer is select from here. This sorry, okay, yeah, is selected, and the gold layer is here and here. So 3 and 4 is the gold layer. Okay. So now you have to collect the real part, imaginary part of gold. So where is the real part? Okay, NAU, N is the real, AU is gold. Okay, K is real, sorry, imaginary, and AU is gold. So you have to write NAU and KAU. Now go. Okay, okay, now and KAU go. Okay, so it's the imaginary and it's the real. Okay, sorry, KAU, not AI. Okay, so what? Isn't it KAU? Uh, okay, it's KU. Why is showing that? Okay, no, it's not showing zero. Okay, then we have to select blank material as analyte. This one will be analyte, and this one is analytes. Okay, so here you can see that we are selecting this one as analyte. Okay, uh, So, so this all part are analyte, and the outer part of the analyte will be the PML layer. So this one actually is the analyte as well. Okay, have you got it? We have to select the PML as the as is the front part of the system. If this part is silica, then the PML will be silica. If this part is gold, then PML will be gold. Okay. So the refractive index of PML is Na. Maybe I can show you. The refractive index of PML is Na. We selected Na is equal to 1.42 right now. So you can sense it actually from here. 3. Okay. So this is analyte and imaginary part is kind of 0. So that's the thing. Okay. Now what we can do, we can now study run this model analysis. So okay, another thing you have to do. So here you, if you can remember that from mode analysis, in mode analysis we have to copy this refractive index and we have to paste the refractive index here. Source mode for a round shift. Okay? Okay. Then you can just compute it. Okay. Then you can just compute it. Let's see what happened actually. Okay, if you think this uh, video is helpful, you can subscribe our channel. If you don't, then no need to subscribe. That's okay. Okay. Okay, it will take some times. I know. What the hell is it? I'm sorry. I don't know what I did, but this was not the thing that I was expecting. Delete the surface. Okay, now let's see what's going on here. So the silica is gaib from here. So what happened actually? So let's source in mesh. Okay. So in the mesh, we Heterodron didn't select the actually the this kind of structure. So we have to select it actually. I'm sorry. Okay, we have to select all the model actually. Okay, that's it. So then build all. So I'm sorry, mesh was bad. That's why. So compute again. Sorry for the bad thing. Let's see. Okay. So if you are working on PCF-based SPR sensor, you may actually face some problem to choose your model or choose a unique model. So you don't know what's the purpose of life. Sorry, what's the purpose of the sensor design actually. So then you can comment. What's the problem you are facing actually? So here you can see that the model is working perfectly. So now we are happy actually, right? Our model is working perfectly. So from arrow surface, you have to select this one and this one. So this is the Y polarized light. So you can search for X polarized light as well. Wow, this is the surface plasmon resonance. This is surface plasmon resonance. Let's see. Yeah, surface plasmon resonance happening. Okay. Yeah, another surface plasmon resonance. Okay. So here you can see this mode. This mode is not good actually. So this mode is not good as well. Uh, so this one is Y polarized. This one is X polarized. So here you can see this is very interesting. This is the surface plasmon resonance, okay, of X polarized light. Okay. Okay. So here you can see that for X polarization light, the surface plasmon resonance is working very well, fantastic. But for Y polarized light, surface plasmon resonance is not working. That's must, okay. That's why maybe this model actually works on X polarized light only, okay. They didn't work for Y polarized light, okay. That's the reason actually. Okay, okay. This is the SPP mode of the Explorerized light. This is the SPP mode of the Explorerized light. Okay, okay. So for today, maybe this is the last video. I don't know. Oh, sorry. Not this is the last video. Mm, this is the last of this video. Okay, tomorrow maybe our in our next video we'll plot this graph actually. Okay, this one is for 1.42. Okay, maybe we will redraw this graph in our way. Okay, so okay, if you want for now, what I can do, if you want for now, what I can do, I can just draw this two curve for now. This one is the core mode and this one is the SP mode at the wavelength of 940 nanometer at the refracting index on 442. So let's do it at 940 nanometer. The refracting index on 1.42. Okay. So sorry, from materials, what I have to do, I have to select refractive index at 1.42 and at the wavelength. I forgot it. Okay, at 940 nanometer. Okay, so 940. Okay, 0.94 micrometer is 940 nanometer. Okay, you know it. I know it. Okay, okay, so more from model analysis, compute it. That's the thing. You have to just compute. Nothing else you have to do. So if you are facing problem uh, to get the SPP mode, which one is SPP, which one is the core mode, if you cannot find out, then you can comment with uh, the picture of SPP or core. Then I will understand that what's the problem. Okay. Okay. I don't know why this is like this. Okay. So this one is the core mode. This one is the core mode. Maybe okay, it's okay. This one is the core mode. So as you can see here, their model has some resonance, but we don't have any resonance. So what's the problem is there is some problem. I know there is some problem. Obviously, there is some problem. In our simulation, there is some problem. We have to find out what's the problem is. Okay, we'll find out in our next video. Okay, so we have to search the SPP. Okay, this one is not SPP for the core mode. this one. Where is the SPP? Okay, we didn't get SPP. We have to increase the more number of modes. Okay, we have to increase it to 20, maybe 20. If we search for 20 number of mode for 20, then maybe we can get the SPP for the code. So in our next video, we'll try to fix the problem. So the problem is here, you can see um, the problem is the core is not, sorry, the core mode is not the same as the paper. Right, right? The core is not the same as the paper. So thickness is 13 nanometer. We selected 13 nanometer, right? Isn't it? We selected it's 13 nanometer. Okay, so geometry, did we did anything wrong? I don't think so. We select this as 13 nanometer. This one. It is 30 TG, right? So this one maybe is 13 nanometer, isn't it? From, you can see from, what's the problem of it? Okay, from 14.4 to 14.43 micrometer. So in nanometer, yeah, 13 nanometer, right? Yeah. 0.4 to 0.43. So it's 13 nanometer, right? Isn't it? So yeah, it's 13 nanometer, but I don't know what's the problem. I will try to find out the problem, okay, in our next video. So thank you. Thank you for now. See you later. Allah Hafiz.